Okay, so let's get good. I wanted to give this talk because, as I said, I myself struggle a lot with this tool. Even though I'm using it daily, and I think a lot of developers do so as well. And it's a tool that, even though it might not be the best tool for this job, it's the most, or it's just became the default. You probably won't find any open source software right now that is not using Git or something very similar to manage its source code. So that's why I wanted to show you how this tool works and also how it works in the terminal, because you might have used it with some plugins and integrations in other IDEs, but maybe for your next job you need to switch IDEs. And if you once learned it, how it works in the terminal, which is here on the left, you will be comfortable with it on any kind of, in any kind of environment. Okay, so what even is Git? The Git docs are, well, you kind of see why this was built for kernel developers, because this is kind of their opening paragraph. It's a free open source distributed version control system designed to handle everything from small to very large projects, yada yada. It's a version control system. And let's even skip the distributed part for now. So what is a version control system? If you ever written any text or created any project, and it doesn't even need to be a coding project. It can be, I don't know, a LaTeX file, anything that is in text files. So not binaries, but things you can, yeah. I would say if you can open it with cat, it's a text file, and if it's still legible to you. Okay, so you might start by organizing your stuff, and you have a project folder on your system, and you might also then try to make everything super clean and tidy and have source folders and try to put everything in its place. But at some point you might want to try out something and you don't want to touch the other files. So what you do, you just make a copy of it, and now you have a project version 2 and a project version 1, and you just copy over the changes. Maybe you are lucky and get or are working on a project that gets finished at some point, so you would have a project final version, which might be different from the other two, and we all know how this ends. Of course, you will end up with a project final for real this time. Yeah, we've seen this. This can live in a Dropbox or a Google Drive or whatever cloud file storage you want, but this is not a professional way to manage versions of your stuff, of your project. So what is a better way? Well, using Git. And putting this quote here, maybe some remember this old joke, Git gets easier once you get the basic idea that branches are homomorphic end-of-function functors mapping submanifolds of a Hilbert space. It's actually crap. It's references on an acyclic graph. Why did I put this in here? If Git is complicated for you, that's because it is. It's not a skill issue. Git is complicated. And as I said, Torvalds, by the way, it is now 20 years since Linus Torvalds, the creator of Linux, started with Git. He created it to manage the source code of the Linux kernel, and it was targeted at kernel developers and not entry-level developers. Back in the day, it was only the bare bones features, stuff that is now called the plumbing, and all these nice commands that we have today, like git commit, git push, pull, add, and we will see all of them later. This is called the porcelain. So the things of Git you as a user hopefully touch is the porcelain, and there's a lot of stuff going under the hood that you hopefully never need to look at or fix yourself. And I also don't cover them today because I even don't understand them fully. Let's start with using Git in what I call single player mode. As I said, we skip the distributed part for now and just learn about how we can use Git, even if we don't push it somewhere or publish anything. Just if we want to get rid of this project version 1, final, whatever mess, and use it within on our local machine. And the nice thing is, all you need to do, let's say we have this folder here. I have a nice README in here, which needs some work, okay? And I have an index file in here. And if I want to create different versions of this super cool project, I want to put it into a Git repository, or I want to turn this folder into a Git repository. And all I need to do this is running git init. And you see my command line has a lot of plugins, which I can show you later at the beer. It already understands, oh, I'm in a Git repository now, so I'll show you what branch you are on. What this did is creating a new folder called .git. This is where everything Git related is stored. If you remove that folder, this becomes a regular folder again. So it's nice to add Git to any project, and also it's easy to remove it again, as long as you're just working locally. Okay, so not a lot of stuff happened right now, because we just initialized this repository. If we want to, now usually you would edit your files, and after you've done some edits, you want to create a new, if I keep to the gaming metaphor, create a new save point. So I say this is a good state of my project, or this is at least a state I want to maybe return to back in the future. So I can add or create a save point by adding everything that is currently not saved. The dot in this case refers to just the current folder. So everything within the current folder and below gets added to this new save point. And by running git commit and giving this thing a message, I'll kind of save this new save point. I can also run it without the message, then some standard editor, in this case Vim, opens, and I can add my commit message. So this is giving every save file a name. Okay, let's see if I can exit Vim again. Yes, okay, I did it. Okay, Git told me it created a new, this is the root commit, so the very first one on a branch that is called main. We'll later learn about what branches are. This is my first commit, the message. There are 2 files that were added, and these are the 2 files. Okay, so maybe I'll edit my my README file now. Okay, that's what plugins do to NeoVim. And make some changes in here. Whoop, wrong shortcut, okay. And now I want to save again. Sorry, I'm so used to using my shortcuts. I'll try to not do this in this presentation. So git adding everything. I have an abbreviation for this. I really recommend you, if you use Git in the command line, to install plugins that give you all these abbreviations, because as you saw, they become second nature to you, and you don't even think about it anymore. Okay, but I'll try to do it the verbatim way. Okay, second commit. Okay, so what you should remember is how you initialize a repository, adding files to a save point. It doesn't need to be all of them. You can also specify the files that you want to add. It doesn't need to be all of the changed ones. And with git commit, you kind of save or create a new save point. Yeah. So soon your repository will look like this. Usually that's how you represent Git repositories or branches. You have one main branch or one main line of development, and every dot represents a save point. Now the question is, how do I get back to those save points? So how do I restore the repository of the state to the state of yesterday? Because I know yesterday it was still working, today it isn't. Maybe npm got hacked again, but it's probably something I did. So maybe I want to revert to a previous state. Okay. So this is the next command for you to remember. It's called git log, and it shows you a textual representation of this list. In my case, I just did 2 commits, and it's pretty verbose. And it's also not so nice to look at, which is why most people don't like to use Git in the command line, but rather within their IDE. But there are a few arguments you can add to this log command. Like this, you can show the whole graph, decorate it, abbreviate the commits, do them in one line, and then it looks like this. It's already way nicer to look at. And of course, if you're me, or if you're using this more in the command line, you will have an abbreviation for this. That shows you a readable list in the command line. And once you're used to this view, you don't need any fancy graphics or graphical interfaces for Git anymore. Okay, so you don't need to remember. Yeah?
Did you push the commit right now?
I didn't push anything. That's all still local. We'll get to that later. So I just...
So I saw you're signed in your GitHub. Or
I'm signed into my GitHub. Or where did you see it?
That repository still doesn't exist.
I prepared already to create a GitHub repository, but the stuff I have right here is not stored on GitHub right now. So this is all just local, all within this folder. I could be offline and still use any feature of Git, or all these features of Git right now. But good question. Okay. Where were we? Yeah. Okay. Now you see all these Git commits have super long hashes, of which you mostly only need the very first few letters. This is how you can reference any point in time of your Git history to jump back to them again. And the way you jump back to them is by using git checkout and then the hash of your commit. So you would have to first log it out, copy over the hash, and then put it in to, maybe let's get back to this state. Okay, what is Git telling us? We are now in a detached head state. That sounds dangerous. You can look around, make experimental changes, commit them, and you can discard commits you make in this state without impacting any branches. Okay, so it's a wall of text, but it's useful to read this because Git tells you exactly what's going on right now. Even my command line tells me I'm not on main, I'm not on my branch, I'm in a special state. I jumped back in time. We can actually just check the README again. So you see it only contains this to-do. There is the header I previously added is not here. That's in a future commit. But Git tells me exactly what I can do, or also how I can undo these operations. And this is one thing I want to remember. If ever you find yourself in a weird state, just read what's printed in your terminal. And that's also why it's nice to use Git in the terminal, because it will tell you how to get out of this situation. So I could create a new branch from here, kind of a new reference to track this new line of the timeline, or I can check out, or the newer command is called switch, and minus is just switch to the previous branch. So that's kind of the shorthand. I could also, since I know the name of it, switch back to main. Previous head position was this one. So if I now look at the log, I'm back on my second commit again. Or you can use git checkout, you can use git switch. I'll tell you why you should use one or the other later. If you, for any reason, maybe made a mistake and actually want to revert the last commit and kind of get back to this previous state, you can do so by not using git checkout. And by the way, this acute one, that's the way of writing just the previous commit. If you don't want to copy around the git hashes, you can also say use main or the current head or any other reference, and then say, okay, go back 1 or 2 or 3 or however many commits you want from this point. So if you want to really roll back your history and remove or forget the last thing you did, you can reset your current timeline to the previous commit. I won't do it right now here on the left, but you would see you see in the slides. Sorry, you saw in the slides what would happen. So if I not use git checkout, but actually git reset the main branch, I would still be in main. I'm not in a detached head state, but my branch would be reset to the, in this case, previous commit. If I put in a hash, I can really jump back to any position. So that can be a bit dangerous. Or actually we have a bit of time, so maybe let's do it. So I reset to this state, and okay, if I do a regular reset, my git history now contains only the first commit, and all the changes I did in the second one are currently unstaged. So it's like just before the point in time where I did the commit. So I can redo this, maybe choose a better commit message, or fix the few things that I messed up and just realized in later on. So I could just do the git add again and git commit. Okay, now I have 2 commits again. Yeah. If I would happen to do a git reset hard, I would even throw away these, I would land in the first commit again, and now my changes are completely gone. So you see there's nothing staged right now. I'm back on my first commit, but there is still a way to get back this second commit. If I look into a thing called the ref log, that's kind of a log of all the things I did in Git. And I could see that this was the hash I have been on before. So I could check out this one again. Or I think I would need to set main to this one. Was it this? See, that's why I didn't want to do it. Okay. Let's just get back to main. No, wait. Let's see. Oh yeah, okay. Okay, I'm still here. I'll add the files. I commit the files again. Okay. We're still in detached head because I need to. Okay, let's switch to main, even though this is now a bit screwed up. Yeah, okay. This is the point where you should rather Google how to actually. Yeah. That's what you get for not rehearsing your presentation better. Okay. What you should remember is git log shows you your history. Yes?
Is git cherry pick something that you're going to showcase in this presentation?
I'll mention it later. Yes, I could have used git cherry pick probably to get out of this mess, right? Yeah. Okay. So git log shows you your history. Git checkout kind of puts you back in time, but it's not intended but it's only intended if you maybe want to branch off of this previous version in time. Git reset really resets your current working directory state to this previous point in time. And yeah, when I tried this before, I managed to reset it properly to main again. Okay. So I talked a lot about branches, and branches are Git's way to split reality. So right now we've only been on this one straight timeline and we just jump back and forth, but Git can actually split reality by creating multiple timelines or multiple branches. So let's say actually our current repository, yeah, has one commit. That's exactly the state we have locally as well. If I want to try something different from here, I can create a new timeline by just saying, by just writing git branch, and then I need to also name this new timeline something. So by default, your default branch is probably called main if you're in a newer repository, or maybe you'll read master if you're in some older Git repository. But if you want to start a new timeline, you need to give it a name. Let's say we use this new timeline to try out the feature before we push this to the main line. Okay. And if I do this command, the new branch gets created. Let's check the log. I now see I'm still on main, and there is also a feature branch that points to the exact same point in the timeline, but I have not switched yet to this other timeline. And that's what you do with either. The old version would be git checkout. It still works, but I recommend you would use git switch, because you cannot screw up switching branches with switching to commits. So if you git switch to something, it's always a branch. It's also a bit easier to remember for me especially. So I would rather switch to a branch. Checkout can mean multiple things in Git. Okay. Also I see git switch to branch. There is a shortcut for creating and switching to a branch in the same step. You could add git switch -c or -- create to do both in the same step. And if I now create a new commit, let's do this. Let's maybe add a new title here again. Okay. And git commit. Let's do my second commit here. Let's see the history. Okay, so now the main branch, as in this picture, is still on the first commit. And right now, my head pointer, so this is where I'm currently at, is pointing to the feature branch, which is one commit ahead of the main branch. So yeah, this timeline is a bit boring because it's just 2 points. Maybe let's do a second commit. I'll do this here as well to follow the graphics. Let's just touch the README. No, that's not enough. Oh, but I can touch a new file. Okay, so now I just created a new file. I'll add this as well. Yes, I used the shortcut. And by the way, a good standard to name your commits is always this completing the sentence, if applied, this commit will add a new file. Maybe not the best example, but if you later read your commit history and you might cherry pick a commit, as we'll get to later, it's easy to see, okay, when I apply this commit, if I apply all the changes that are this bundle or this commit represents, it's easy to reason about if you use this format. If applied, this commit will then add a new file, fix this bug, update the documentation, whatever. Okay, let's look again. Okay, now we have 2 commits here. Now, if we saw that, okay, this new branch is better than what we had on the main, we actually want to merge all of this because it is nice. We can switch back to main, and I already kind of gave it away, merge both of those together into the same by just telling Git to merge the feature branch into our current branch. And because I just switched back to main before, it knows, okay, this feature branch needs to become part of the main branch again. Let's see if yeah. Now that's pretty boring still in the command line, because I think it did a fast forward commit. Okay. Okay, I'll tell you about this later. Let's, in the interest of time, skip ahead a bit. What you should take away is creating new timelines you can do by creating Git branches. You can switch to those timelines by using git switch, and you can bring them together with git merge. And hands up, whoever had a merge that felt like this, like maybe a conflict happened? Yes, of course, of course. So how are conflicts made? So if two branches really like each other, no. If you make, so Git tracks the changes in the files by not storing a whole copy of the whole file, but really remembering, oh, you changed line 1 to 3, and this is the old, this is what you changed in those files, or in those lines. Or it just remembers you deleted this file. So maybe let's do just that. Let's switch back to our feature branch, and let's remove the new file. Okay. If applied, this commit will get rid of this unnecessary file, and I think I made a typo, but it doesn't matter. Okay, now we see, okay, we deleted the file. Oh, I don't need to push anything, I just need to, I forgot to add, thanks. Git add. So let's show, I can show you it also works if I just do this one file. Yes, okay. Now I did it for real. Now one file changed, it was deleted. Okay. And let's say I switch back to main. And on main I'll do something different with this file. You see on main this still exists. Let's create a valid JSON file. Should be easy, right? Okay, maybe just this. Now edit, and I commit. I added some content. Okay, let's check our history. So we are here on main. Oh, yeah, let's see all the history. Ah, now it looks a bit more interesting. So on the very left, you see the current main branch where I added content, and you see that the feature branch did something different. This is where we got rid of the file. So if we now merge these two, we'll get a conflict. Nice. And again, Git tells us exactly what we should do. So there is a conflict. It was modified in one branch and deleted in another. The version of a new file is left in the tree. The automatic merge, so usually it tries to just bring them together automatically. If your changes don't overlap, it can just merge or interlace all these changes into one consistent state. If it can't, it will tell you. And if I just write git status, that's also a very helpful command, I could see, okay, I'm on branch main. I mean, that's clear. We didn't switch branches, we just tried to merge. And we can fix the conflicts and then just run git commit to get out of this currently a bit broken state. Or we can also abort what we just did and get back into the previous state before we try the merge. So it gives me actually multiple options. Let's see. So there's a new file JSON. Let's look into this. I should have used a different example. Okay, let's say I want to keep it, so I commit it. Okay, now we're fine again, and if I look at the log, now we see that I could have used a different commit message, but now the branches are merged again. If I would have wanted to delete it, I of course could delete it. As soon as all the files that are in conflict are resolved, Git will let me know, and I can just commit everything. Maybe you could commit in a broken state, but then you'll get very angry colleagues.
Sorry?
Yeah?
Is it a simple terminal of macOS?
This is, it's not the default macOS terminal. I can show you later.
Okay, it looks much cooler, yes.
Okay.
It shows branch and...
Yeah, I can show you later how you get all of these features. Terminals don't need to be boring and look awful. Okay. So we saw how conflicts were made and how we could resolve them. And the takeaway here is maybe do a git status, check what is going on, read this wall of text, and understand what Git tried to do, and it will tell you how to get out of this situation. And if you're not giving a presentation and are under stress, you might even do the right things and get into a working state again. So what you should never need to do is remove the whole folder and reset it to, or clone it again from some repository. Actually, since we're currently working in single player mode, just locally, I wouldn't even be able to restore all of this from somewhere else, because right now I haven't pushed it yet. Okay, but we'll get to that. One thing we saw before was this fast forward merge. So actually my branch did not look like, or my history did not look like this. It actually looked like this, because Git realized, hey, I don't need to do this detour. I don't need to create a merge commit. If all of the changes are newer than this other branch, I can just kind of flip it over and have one straight line of history. And some people are very, and I myself for some time tried to keep all my repositories with a very clean, readable Git history, so everything trying to be super straight. And it's easier to go through your Git history and figure out what you did in the past if it is a straight line. Git can create this straight line, even if you did branches, if it's able to do a fast forward merge, which, as I said, can only be done if there are no newer commits on main, and I can just kind of flip this branch over to main. So let's say, let's say we did this branch, but it was created from commit A and something else happened. Maybe your colleagues or somebody else or you yourself created commits on the main branch, but you want to get into this shape to be able to maybe do a fast forward merge. Or you just want to change the flow of time. So you saw that there are changes, but I don't just want to merge them in. I actually want to act like my changes came later. So I changed the history of, I actually changed the timelines. And what I'm getting here is how rebasing works. So what a rebase does is it takes the base of your current branch. Let's say I'm on the feature branch. It was based off of this commit A. And if I rebase on the current state of main, which already contains a commit C, so something else was committed, my commit or my branch gets moved on top of the other branch. Why is this tricky sometimes? Because if you get a merge conflict here, the current change and the incoming change, or the directions are reversed. So if you ever had a merge conflict in your IDE, it usually shows you this is your version and this is the incoming version. That's what's happening on a normal merge. On a rebase, what Git actually does is, if we're in this state and we want to rebase feature on main, it first switches to the main branch, like goes to C, and then reapplies B on top of main branch. So of course, now this one is the incoming. This is the incoming change, even though you ran this command while you were still on the Git on the feature branch. I hope this was clear. Okay. So, okay. Okay. So just remember, if you're doing a rebase, the directions of the changes will be flipped. Don't read the docs why this is happening, because the docs are a bit verbose. Okay, now let's finally get to the multiplayer mode. And yes, this is the scene where Leroy Jenkins stormed ahead. It's fun to organize all your stuff, but it's even better if you can do this and share it with your colleagues and also see all their changes, and then hopefully not have too many conflicts with them. So first of all, Git and GitHub are two different things, just like porn and Pornhub are two different things. They're related, but one can work without the other. And also there is not just GitHub, there is what is called Codeberg, there is GitLab. It's kind of a open source, self-hostable version of GitHub. And GitHub does more than just host your Git repository. Okay, but GitHub is a very popular hosting provider for Git repositories. So it's because it's free for public repositories, and it's easy to share your code or your projects, whatever they are like, with other people. And I have a GitHub account already, and I started a new repository. Or let's just create a new repository here. So once you have a GitHub account, you can just say this is a repository that belongs to me, and I want to do give it a name. I don't give it a description right now. Let's make it private so not everybody sees the weird things we're doing here. Okay, this was pretty quick. GitHub already tells you how to either, if this is your starting point, get started in this repository. That's this block. Or if you already have code like I do, how do you push your current code into this remote repository? So sometimes you might start out locally and then you realize, oh, actually it didn't turn out that bad. Maybe I should share it with the world. In this case, what you need to do is add a so-called remote to your repository. So that's one concept in Git. And let me do this here by copying over just this command. So what this does is it adds kind of a, it's called a remote. It's a reference to some external tool like GitHub that tracks or that can track my changes as well. I don't need to rename my branch. Maybe I should zoom this up a bit. I don't need to rename my branch because it is already called main. But now I can push my changes to this origin. So what we did here, we added a remote. It's called origin. That's kind of a default name. And this URL tells us where this is living. And because I've set up everything correctly, my terminal knows how to authenticate against GitHub. And this will just go through. Perfect. So now this branch main is tracked by origin main. And the thing is, this origin main and my local main, these are two separate branches. They are connected. Git knows that one is tracked by the other, but think of them just like feature and main. They are still separate. Okay. Let's just refresh this website. Now I see my files are here. And all I have here is this main branch. I didn't push the feature branch. So I can be very selective with what I push and what I try to track. Okay. You can do a git push. Maybe I did this before. I think it's all with tags or something. Git push all. Yeah, let's try this. Wait a second. Push all references. Yes, that's it. And now we see there is a new branch feature that is also tracked by feature. Good question. Yes. Yeah, that's maybe a good idea if it's the first time you push to a remote repository to also push all the other branches. Okay. Let's speed up a bit so we have time for the second talk as well. Okay. So only on the very first time you need to set this origin. And now that there are changes, or now that this thing exists remotely, I can also pull the changes again. Well, now nobody made change. Oh, actually I could. I can use the web interface here and create a commit. No Copilot, I don't need, okay. Okay, or maybe some bot edits did some changes. Let's pull again. Now one file changed. Now I see the change locally that I made in the web interface. Let's see in the log. Yes, add nice to readme. So this was done also by myself, of course, because I was logged in. But this is how you could get all the changes your colleagues are doing. And you can, of course, not just pull the current branch you're on, but also put in the reference of the branch that maybe somebody else pushed. So you don't need to pull everything. You can just selectively pull the ones you need. And one thing that's important, if you don't want to also overwrite your local changes, but just know about that there are changes, you would not do a git pull, but a git fetch. So this is updating your local view of the world or of the timelines, and you would know, or your local machine would know about the references. And yes, there is a git fetch all, but it does not overwrite your changes immediately. Yeah?
I heard that if you edit the code in GitHub website,
Yeah.
and then pull it,
Yeah.
that it can cause some complications. Is that true?
Yeah, that's why I said this or the thing that lives in GitHub and the thing you have locally. These are still two separate things. There is no auto update. So if I change something here and at the same time make similar changes or change the same file, I could again run into the merge conflicts. So when I do a pull, it updates this origin main, and then it tries to merge them into my local main. This is how you can, of course, run into issues if you change something in the website or in their web IDE. They have a fully fledged VS Code in there that you can run in the browser. Yeah. So again, two different branches, even though they sound the same or appear the same, in the end they just get merged. Okay, so now we know how to publish our stuff. Yeah?
Actually, I wanted to say using the web interface for GitHub is not worse than a colleague working on the same project.
Yeah, exactly. So.
You don't have to fear it.
Yeah, exactly. So using, just to repeat for the video, using the web interface is just the same as if somebody else would make changes. Yeah, usually you would run into merge conflicts if multiple people work on the same thing and overwrite the same files. Ideally, your project has not everything in a 1,000 line source code file, but has it spread out over multiple files. And you maybe talk to your colleagues before you make changes so you don't step on each other's toes. Okay.
Sorry, explain this again, difference between pull and fetch.
Yes, and I have the perfect slide here. So this is as deep as I'll get today. So there's this working directory. This is what you see on your file system. These are the files you can edit. There is this staging area. This is the files that you, or the changes that you intend to commit for the next kind of save point. This is so when I git add, I just say, okay, whatever I changed right now, let's prepare it for the next commit. If I do a commit, I update my local database of all changes. And only if I push it, I'll let the remote know about it. If I do a git pull, I do two things actually. I would do a git fetch, and this arrow is unfortunately missing in this, but I didn't have time to make a better graphic. If I do a git fetch, I'll just copy the changes from the remote repository into my local repository, but I don't override my working directory. I don't override any files that my file system sees. I only change stuff within this .git folder in its internal database. If I do the git pull, I do both at the same time. I fetch, so I update my local view of the world, and I also merge it with my current local state of it. Did this answer your question?
Yeah.
Okay.
And git checkout?
Git checkout is really just to switch to a different reference. Or you could also use git switch if it's a branch that you're switching to.
Oh, yeah.
It's a lot of commands, but I'll link to a good cheat sheet at the end that lets you know about all the commands in case you didn't remember them. And of course also the slides. Yes, there is the force, and you should learn when to use the force. Of course you could just use it all the time, but then again you get into this issue of angry colleagues, which I hope you don't want to have. When should we actually need the force? It's pretty simple. Whenever we change the history, so if I do a rebase, I showed you how the history changed because I said, oh, these commits were actually done after something else. So I changed this tree. In this case, I would need to push with force to overwrite the references of a specific tree on the remote. And in case somebody also changed something on the remote, let's say I push with force to main, but somebody else already made changes on main, I probably don't want to override those changes. So what I would want you to use is always the force with lease. And I don't know why this is not the default, but yeah.
Because it's not fun.
Because it's not fun. Actually, I looked up I have a shortcut to git push with force. This always does a git push force with lease and even 2 more other options. So this command always checks, are there changes that I'm not aware of? If so, I stop what I'm doing. And if there are no other changes, okay, let's override. We'll get into this a little bit more, but let's get going. Yes, so there are multiple ways how you can use Git in a team. I'll just show the most prominent 2 versions. One is called the approach of using the Git flow, and the other is called the trunk-based development. And yes, I know Mermaid has a weird issue there. Maybe I'll get to fix it upstream. Okay, so what Git flow is about is if you work in a team, you might have one main branch, and the state on the main branch is one that you are good with, that is good to be shipped, to be released to your customers or users or whatever. There is a develop branch that is kind of representing the state of the current development. This can also be hopefully working, but maybe not the fully fleshed out new version. And then all these features like, okay, I now added the new button, I now updated the Jenkins pipeline, whatever. This is done in smaller feature branches. They all try to get integrated into a development branch, merged. This is probably also published in some environment that other developers can try out. And only once you feel good, or the whole team feels good about it, hopefully at the end of your sprint you have a version ready, you might create a release branch first, that then where you do things like updating your changelog or smaller administrative stuff. And once the kind of release is ready, you merge into main, and then the version of main gets maybe a new tag. Oh, by the way, you can also add references in Git called tags that kind of mark a specific commit in the history. Okay, so this looks complicated, but it's actually a nice pattern of working that prevents you from stepping on each other's toes, because you would always have a working version of main. Whoever gets into this project and just wants to try it can be assured that whatever is on main works. If they're curious, they can check out develop or dev or whatever you call it. And then every developer who takes a new task develops it in their own feature branch, and this develop branch is shared, the main is shared, the feature is hopefully not shared. So you would not branch off somebody else's feature branch, because if they do a rebase, you'll get into trouble, but you would not rebase the develop branch, you would just merge into it. I know I'm going over this a bit fast, but we don't have that much time left. So the alternative to this is called, what's this question? Or okay. The alternative, and I quite like this approach, but I'm fine with both. It's called trunk-based development. This is where you always, you don't use a development branch, you always merge towards your main branch, and you hopefully have good checks in place to make sure this is still working. So again, you use feature branches to do all the small incremental improvements of your project, and then merge them into the main branch. And if you need to release something, you then create a release branch where you say, okay, this is now version 1. We can work on newer things, but if we need to do a hotfix because we found an issue in an older version, we can add to this release branch and maybe apply one commit here that just fixes a minor thing, create a new release. So these would not get deleted or merged or anything. You would always keep your main branch running, or this is kind of the state of your project, and only for when you want to release or do a hotfix, you would even add these release branches. This all ties together with how you run automations on top of your Git, which we'll hear in the second talk. Let's maybe first, and this is the last section of this whole way too long talk, get into a few more cool features, and I have not prepared demos for them because I would definitely screw them up, that you probably never use, but it's nice to have heard of them because now you know what to Google for if you need them. Cherry picking, okay, actually I sometimes use this. This is where you don't merge a whole branch into your current state, but just a single commit of it. So again, you need to reference this commit by its hash, but it's really nice because you can say, okay, maybe I'm on a release branch and I just need this one fix that was already done way ahead on main or wherever. I can use this one commit and apply it to my current state. Or my colleague has done this cool thing, I want to use it, but I don't want this whole branch. I'll pick the cherries with cherry pick. There is a nice version of git add that is interactive. Maybe I actually can show it to you real quick. Okay. And let's also change something about the README.
Do you have to be on the same branch to cherry pick?
No, you can cherry pick from anywhere. So I would usually just do a git fetch, so I know about the changes somebody else made, maybe git fetch all, then check my history, which should also show me, or could also show me changes that are ahead of my current state, and then I can select the commit hash and use this to cherry pick from it. So can be from any other branch. Okay, so here I made 2 changes, and if I use git add interactive, I get this thing, which looks daunting, but it's actually quite nice. It shows me what is staged, what is unstaged, and I can say, okay, let's do some updates, let's add the README. Now it gets a little star. I don't want to add the other thing, so I'm done already. Yeah, now I'm done. And let's check the diff once again. Okay, only this was staged, the other one was not. I'm done, I can quit out of it, bye. And if I go into git status, okay, now you see only the README was staged, the other one was not. Now I could do my my commit, yes. So it just should show you there are some nice helpers within Git called these interactive modes, which make working with Git in the terminal even nicer if you're used to it. So of course this takes a bit of training and building some muscle memory. Okay, let's remove this and can also push this. So now you saw me, I did a new commit. Yeah, I can also push stuff. Yeah, now my local state and the origin, so the remote state is at the same state again because I pushed my changes, and I still have some changes locally that I have not changed yet. So there is still something unstaged locally. And again, git status tells me, hey, by the way, there are still changes you have not saved or pushed yet. This is how you do it, or this is how you undo them, like git restore. Okay, now we're clean again. There we go. Okay, so this was interactive adding. Let's switch to the feature branch and do a git rebase, and also do this one interactive on main. Okay. Okay, there are no changes. Should have done some changes first. I'll skip over this in the interest of time. What git rebase interactive allows you to do is, for every commit that you made on this other branch, it allows you to pick if you want to drop it, edit it again. Maybe you want to stop and kind of revisit the changes you did. Maybe you just want to rename the commit message because now you saw, oh, actually this is not helpful to my colleague. I should put in something better there. Or you can also squash multiple commits together. So interactive rebasing is really the tool you need to clean up your branch before you push it and show it to your colleagues so they can see, okay, you made this commit, which is kind of one coherent set of changes, and then another and another. Okay. If you ever run into the situation where you know there was a working state of your project sometime in the past, maybe at version 1, but your current state, the head, is not working, you can use git bisect and say, let's start between head and version 1, and then git allows you to jump between those two states and kind of does a binary search through the commits. So it will pick something in the middle, and you can maybe run your tests and say, okay, this is still good or this is bad. And this allows you to do a binary search to figure out when a certain issue occurred. And once you're done, you can do git bisect reset and are back on your current state. I've never had to use this, but it's good to know if you want to find like what caused this issue in the past that I only experienced now maybe. Also a thing that might be helpful, maybe you have an environment file and you put in your secrets, but you don't want to push those secrets, so you can tell Git, by the way, keep this file, but don't track any changes. So this is why it's good to understand, oh yeah, there is this index in between my working tree and the local state. I can update this index and tell Git to not track specific files. There's then also a different option to undo this again, of course. Oh yeah, and maybe one last thing I want to show you.
Does that create a git ignore file?
I mean, yes, you can also use a git ignore file if you want to ignore certain files in general, like your node modules folder. You should probably not push that to GitHub.
It's not the same.
It's not the same. So git unupdate index assume unchanged would still keep it within Git up until that point where you stopped tracking it. Yes?
Is the index shared? Like, can I push the index or is it local?
Your index is something local. Your index is really the collection of changes you want to put into the next commit. And if you run this command, any changes to a certain file won't be indexed anymore. But the thing is, everybody needs to do this in order to not track the changes anymore. So yeah, maybe not the best thing in a multiplayer mode. Maybe just use a git ignore file to say, okay, we don't track this file. And for environment files, it's actually a good strategy to just have a .environment.template, and then everybody makes a copy of it, but never pushes the actual environment file. So you're right, this should actually live in a git ignore file. Should have mentioned this. The work tree, yes. Sometimes you want to switch between two states of your repository, like you want to switch to main. So in this folder on my machine, in the /FreeCodeCamp folder, I can only ever check out one branch. But with git work tree, let's see the list. Okay, there is just one. It's on main. I can check out a second branch, or however many I like. And it's best if I don't do it within the same repository, otherwise I'll kind of get a mess. Maybe I'll go one level up in my directory structure and do a FreeCodeCamp-feature, and this one is meant to track the feature branch. Okay. So if I now list my work trees, yes, I can see, hey, you have two folders locally. Those are tracked by the same Git repository, but they're actually on my physical disk. So I can just switch over to the other one. And here I see I'm in the feature branch. So this way I can check out multiple branches without cloning the repository again and again. And it's just one source of truth. So if I ever do a git fetch, it updates all the references for all of them.
But if I did changes to the second folder, would those
Yes.
be tracked in the git of the main folder, or would that actually be tracked in the second folder?
I think it's in the git of the main folder. Let's try. I think the second folder just has a reference to the first one. Okay, let's try this. Let's add everything. Git commit. Okay, and actually we can do a, yeah, so there is still a Git folder in here. If we switch back to the previous folder, and log the whole history, yeah, we would see the commit that we did in the other one. So they share their understanding of the same Git repository, so you don't kind of copy the whole database locally.
What's the use case for this?
Well, if you need to have 2 branches checked out locally, and you maybe work on both of them, I mean, there are other techniques you can do. You can also stash your changes and then switch the branch, work on this one. I don't know, stash it again, switch over, undo your stash.
Have recloud codes running at the same time.
What was that?
Have recloud codes running at the same time.
Oh yeah, actually, yeah, for AI, this is a pretty good use case. So you can say, just work on this folder, and you can use all its tools to make modifications, but you can still work in your folder. Yeah, that's actually a pretty good use case. Okay, and of course, we heard you like Git, so you can of course put Git into your Git. So you can add submodules that won't copy over, or that won't just be a copy of all the files, but really track another Git repository as a subfolder of your current Git repository. I've done this in the past. I've always ended up with issues. It's possible. Read the docs carefully if you want to do it properly. So all you need to remember of this slide is nothing. The names of the commands or the existence of it. But this is really something you should read up again on if you ever need it. Just wanted to let you know about a few of the advanced features. It's pretty good summarized in this meme. In the end, it's just a few commands you actually really need. And if you want to do yourself a favor, you create some, or you install some plugins that create shortcuts for them in your terminal. So you can use Git in your terminal and don't need to get used to any specific plugin of any IDE. Okay. In case you do want to look up anything that was relevant, there is a Git cheat sheet. That's really the best page of the whole Git documentation. And this is the link to it. You can save this one. This contains everything I've showed you and has nice diagrams that explain again what was a rebase, what was a merge, fast forward merge, how you resolve conflicts. Not all the advanced features, but the most important ones really. Okay, and if you want to check these slides again, the link is here. More about myself on my homepage. And if you want to know about how I made my terminal look this nice, let's talk at the beer. Thanks so much. Let's do a short break. Have some food and then get ready for the next talk.